So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. Now, this week we're talking about solar and battery systems, but not the systems, the customer service that's necessary to keep these systems running. Regular rooftop solar systems, those ones with just a single inverter and no complicated batteries, they've been typically very, very reliable. It's a simple inverter, no fancy rooftop electronics, reliable panels, and even on these systems, ideally no monitoring, because the monitoring is something that always goes crazy. But the basic systems that I've been installing since 2001, pretty reliable. But when a battery's involved, kind of like Murphy's Law, now that there's many more things that can go wrong, they go wrong. So there's extra electronics added to every solar panel, optimizers, microinverters. The batteries, they're sometimes modular, there's sometimes multiple batteries, there's sometimes, huge batteries, battery management systems. The inverters are sometimes built into the battery, sometimes they're separate inverters, and there's different manufacturers. That's tricky. There's something called an automatic transfer switch that automatically isolates the home from the grid if there's a blackout. There's EV chargers that sometimes are integrated. There's electrical changes that are made in the house so that you can do things like load management. That's kind of tricky. There's controllable circuit breakers for large appliances. So if there's a blackout, it might automatically turn things off, which you want to save the battery, but that's a little complicated. There are these things called CTs, or current transformers, and they monitor power flows throughout the entire system. They have to be put in exactly the right place in the right way. And to add insult to injury and all these other complexities, the software is really complicated. You have a customer application that they have on their phone. You have installer applications that help us get it configured. We have administrative applications so we can see how our whole fleet of batteries are working. And then you have firmware on every single component. And so all these things kind of add up with the communications and the wireless data that's going back and forth. It's just complicated. And so what happens is there's some issues that are involved, and they need even more customer service. I remember when I first started installing the lithium-ion battery systems, every single one of my lithium-ion battery system customers was on speed dial on my phone, just to kind of get everybody working. So here are some of the things that we learned after many years of installing and servicing battery systems. First, a rooftop solar system, once it's over about 15 years old, it's often too fragile to upgrade with the communications and the extra circuitry that are needed for battery systems. Some manufacturers with battery systems have really complete, reliable systems with very low failure rates. Some manufacturers have systems that are integrated from multiple companies. The battery makes one component, there's an inverter from another company, there's a transfer switch from a third company, and it's hard to integrate all these things. In our experience with these multiple company integrated systems, they have higher failure rates, both because of the hardware, but also because of the software that's just not perfectly working among the components. Now, the obvious thing you think about failures or issues is there's bad manufacturing. That's not as common as you think. The manufacturer has been pretty good. There's been buggy software, and that's been a bigger issue. Even among the big companies, it's okay if there's a bug that just makes the app cumbersome to use for a day or two until they fix it. But it's not okay when there's a software bug that kind of actually break some hardware. That's happened to us. And some manufacturers have really good customer service responsiveness, and some manufacturers have outsourced it to what seemingly are oblivious service people just following a script. And so that's tricky. We have to deal with it as an installer. Customers also have to deal with it because we can't always get the answer to our questions. So a large part of our service business, the majority of it, really relates to correcting and updating battery system firmware and also fixing bad battery system hardware. Now, we track all of our service calls, all of our failure rates, and all of our RMAs, return material authorizations. And RMA is basically the permission that a manufacturer gives you to send something back. We track them all. And here's a graph showing the RMAs as a percent of the total battery installations for 4 battery system suppliers. I'm not going to go into the names of the companies right now, but it really shows you the variation among major suppliers. Some companies really have their act together. Some companies used to have their act together and they lost the act. And then other companies are maybe going through some teething pains with new products. But it's a huge variation. I mean, one company's down less than 1%, and then other companies over 60%. Obviously, we're not making any money if there's failure rates that are even over a few percent. When it's 60%, it's a nightmare. All right, so now here's the key. Let's dive into how we provide solar and battery system service. We use a mix of in-house service coordinators and outside field service technicians. They're all our employees. They've all been trained on a wide variety of common solar and battery systems. And they're motivated to solve customer problems most efficiently and at low costs. And so I'm very proud on this energy show to have 4 of our customer service team members here. I'll just start off with Frank Teague. He's been with me for a long time. He's got a degree in construction technology and joined my previous solar company, Akina Solar, in 2007 as a lead installer. And Frank, I still remember you being on the roof with me at 605 University Avenue, which is like a half a mile down from where our office is right now, removing the system that we had installed on that building's roof. We were taking the panels off and they were ballasted with sandbags. I still remember that. He's one of the smartest and effective technicians I've ever worked with. Our other key field service technician is Lucas Cordero. He joined the solar industry in 2006. And over the past 2 decades, he's worn many hats, hard hats, baseball caps like he's wearing right now, and just, metaphorical hats as far as doing installation work, planning, management, and service. He's terrific at troubleshooting and fixing these lithium-ion battery systems. There's a woman named Lily Cinnamon. Well, coincidentally, yes, she's one of my children, and she's the only one of my 5 kids with the brains and the bravery to stay in the solar business. Here's a picture of Lily on the roof back in like 2001 at her very early stage. She joined the Cinnamon Energy Systems team in 2020 to provide customer service on the phone. And then finally, last but not least, we have Yvette. She started at CES in 2023, and along with Lily, she provides remote troubleshooting and coordinates our service activities with customers and our field service technicians. So welcome to the show, team. And let's kind of dive right in. And this is round robin. And so, raise your hand or feel free just to chime in. But let's just talk a little bit about the typical warranties on batteries, inverters, and solar panels. What are some of your comments on those?
So the warranties are great and they include the products themselves, but what is not commonly disclosed is that they do not include the labor to troubleshoot for the product to be replaced or the labor itself to replace it. These manufacturers also can change these warranties over time, and the warranties make the installer go through a lot of hoops in order to get stuff approved, and certain manufacturers are better about approving things remotely, and other ones make us go through more hoops, which is more labor fees to the customers that, of course, these warranties manufacturers aren't covering.
Yeah, any other comments on how well manufacturers live up to their warranty obligations?
I was going to add to your question on the typical battery warranties, which are battery and inverter, which historically since 2007, the standard's been around 10-year warranties. But over the years, different inverter and battery manufacturers have kind of been one-upping that to make their system more attractive for the end user. We have like Enphase adding the 25 for the micros and on the battery. So I think now Franklin's now adding to their 10 years. So now they're above the 10-year for the battery. But over the years, we've had, for the most part, the systems that we work with on a daily basis, we're able to get a hold of those manufacturers. But you have some older like panel manufacturers that are no longer around, and it's like a shot in the dark if you have even a possibility of getting a hold of one of those guys. If the manufacturer is still around, then you might be able to get somebody. You might be able to take your time to a lot of time to get a hold of somebody to actually get something moving, but it can be very difficult.
There's kind of like a death spiral when a manufacturer has bad equipment that it could, really put them out of business, or they want to stick their head in the sand until installers and customers forget about it, and then they try and release new products. So that's an issue with solar panels. A lot of companies are gone. It's an issue with inverter companies. A lot of them got out of the business. And it's also an issue with what I call kind of second-tier battery manufacturers, where they really tried to get started, never got a lot of traction. They're not around to support the product. Let's talk about servicing really old systems. Like, I mean, just let's look at a couple of examples. A sun power system that was installed in, say, 2007, or an old Fronius or PV powered inverter system that was installed 15, 20 years ago. What do we do?
It can be really tricky because with old manufacturers and old equipment, there's lack of tech support. So if there was firmware or portal support that would be needed, which is more so for like newer, like within the last 7 to 10 years, with an old system where the manufacturer went out of business, that can be tricky. But if we're dealing with a system that's 15 years old at this point, we're running into discontinued products. We're running into a lack of inverter replacement compatibility. We're running into mixing old components with new components, and laws and regulations have changed in the past 20 years, and that can make servicing it really tricky if it's not just a quick fix that Frank and Lucas can do as bypassing a couple panels. It is tricky the amount of money that you want to invest in a system that's not working, that's 15 to 20 years old, rather than at that point upgrading it to a system that can fit your needs and not be a money pit trying to repair.
So Lucas, we have a customer that says that their system's not working right. The output is way down, and it was installed in, say, 2009. What do you do when you go to the site and it has a string inverter?
First thing is that sometimes when the systems are that old, efficiency will be down. And with the string inverter specifically, you can have an ultimate failure. Sometimes the panels on the roof are still in good shape. A lot of times what we see is when you're adding new components to an old system, the old system will have had different code compliance. So it won't necessarily be up to date with the newer equipment. So although the panels on the roof might still be good, the system itself won't be able to work with a new inverter. It's going to be too sensitive. It might throw an error. And also, speaking on old equipment, I was going to add to Lily's, sometimes manufacturers have changed hands too. So when you were going out to an old job, maybe the homeowner is saying, oh, well, look, this warranty is still good, but that company's changed hands a couple times. And so now we're kind of chasing a rabbit down a hole to get to a point where we might be able to replace a product.
I just remember a situation in San Jose where there was a customer with an old rooftop system using BP solar panels, and a basketball had cracked one of the panels. And we went out to troubleshoot it, and we said, well, this panel is broken. So we replaced that one panel, and it was hard to do, and it wasn't one of the BP solar systems that were recalled. And we turned the system on, and then the panel right next to it started smoking because now the full power was going through all of them. It's like, it's you got to just replace the whole thing for some of these really old systems.
They've got good use out of it at that point. You had 15 years of good use, so sometimes that's the case.
Frank, any experience with really old systems with really old panels that we fixed one and things got worse?
Yeah, I think it's just like anything that's been sitting around for a long period of time, everything slowly deteriorates. So I was just at a site yesterday or the day before where this lady had a really old system installed by another company, and she had her garage door worked on. So for whatever reason, those people turned off the solar breaker or the disconnect, and when they did that, her system never came back on when they turned it on. And so when I got there, I went and looked at it, and I found that this disconnect had a blown fuse. And then when I started turning it back on, I noticed that the disconnect itself had a loose connection in there. And so for whatever reason, it's been working for 15 years, but now that it's been turned off and back on, it's no longer any good.
You fixed it with a screwdriver.
Yeah, this system has 2 disconnects and a breaker, so I kind of bypass that disconnect just so that her system can work.
Which is okay based on current code.
Sometimes the best thing we can do on an older system to get it working again is to bypass the old components or a couple components so it can work at reduced capacity rather than swapping out equipment.
That makes sense. All right. It rained last week and the week before and the week before that. And rain is the biggest contribution to roof leaks, which sometimes happen from some mistakes that are made on the roof. What about roof leaks? What causes them, and how can they be prevented?
Roof leaks is a little bit tricky. because there's many things that can cause roof leaks. I would say sometimes the debris on the roof could cause the roof to leak. Sometimes it could be like a small little hole, that's on the roof per se, maybe from the equipment of the panel. It's really tricky to pinpoint, especially to pinpoint where the leak is coming from. Like, I know sometimes we have customers that say, oh, it's directly coming from under where the panels are installed, but some of the times that's not where it's coming from. It just looks like it would be coming from there. So I guess it's just kind of hard to say where the roof leak is coming from. And it takes, a roof lead to go and have to get on the roof to check it.
Sometimes crawl around in the attic.
Their favorite part is crawling in the attics.
Good installation procedures really minimize the roof leaks. What are the keys to minimize the chances of roof leaks?
Installation per manufacturer instructions, of course, is the best route when you're using products. But sometimes when you're looking for rafters, which Yvette was touching on there, was sometimes you miss the rafter and you have a hole that's not where you want it to be. And so we have to just make sure that those things are splashed and sealed properly. But we also run into that she was kind of alluding towards was like the damming of water, meaning water's running downhill, so therefore there's a debris and whatnot. So during our installation process, making sure we're keeping our area clean during the installation process, and when we're done, all of our stuff is completely off the roof and not causing a dam. Homeowner has a little part in that too, because if there's trees in the area or other things that could be flying onto the roof, making sure that the roof stays clear.
Yeah, that's one of the keys to our installation practices, to make sure we use full-size flashings, not little micro flashings. And if you do have that full-size flashing, even if there is an inadvertent or poorly sealed pilot hole, it's not going to leak. But I do recall some situations where there was a squirrel's nest underneath the roof, and that creates a barrier, and then the water kind of backs up behind it and even can creep underneath these flashings. Let's talk a little bit about what to do about squirrels or rats chewing on wires.
I mean, for the homeowner, it's really a matter of good housekeeping. If you have foliage leaning against the side of your house, or, easy pathways for a rat or a squirrel, some sort of rodent to get onto the roof, that's just really a no-no. I mean, trees that are planted right up against a house that have, canopies that will lean onto a house, it's the perfect way for a squirrel to get up there. And then they love nesting underneath the panels. It's warm, it's safe. So when we get up there and we actually do see a big squirrel's nest, not only is it a problem for the damming of water, because once water starts damming, it'll find a way to get into a house, but also the squirrels love chewing on the wire and having a little snack here and there. And I think, Barry, you actually have a story about a squirrel having too much of a snack and getting a little bit of a shocking.
Yeah, now that you mention it, Lucas, there was a project that, at Akina, we were doing installations all over the country, and there was a customer in Connecticut that sent us a picture of his steep roof, and it looked like a meteor hit the center of one of the panels. It just looked like a black hole. Boom, a meteor smacked into it. So we sent out one of our crews and lifted up the panel, and it turned out that there was a big squirrel's nest underneath the panel. The nest was kind of mostly charred. You could see where a bunch of wires were chewed. I don't recall if our crew had actually taken a picture of the body. But you could very clearly see that the squirrel had chewed the wires, created a short between one of the wires, its mouth, and the ground, and created a high voltage spark and created a fire. And the system was installed properly, and so the fire never really got into the roof. It just the roof surface. That's what's good about composition shingle and tile. It doesn't burn. But we had to replace a bunch of panels and fix the charred part underneath the roof. And I don't know what they did with the body of the squirrel. Frank, I seem to recall a fairly recent situation where you joined the baby squirrel rescue team.
Found a nice little cozy nest underneath some panels that had some pink babies in it. And the little babies, of course, needed to be relocated. So I asked the homeowner for a box, and so I slid without touching the babies. I kind of slid the much as the nest I could fit into the box. Then I brought it down to the bottom of the tree in which the squirrel had found to get onto the roof with, and so I knew it was going to come at least back to that tree. So uh, I believe the squirrel found its babies at that point, but yeah, I had to relocate the whole thing so that it wouldn't still go to stay underneath the house and or sorry, underneath the array and chew on those wires.
That was very humane of you, Frank. And I actually went back to that house a couple weeks later to help install some critter guard, which is available. And the homeowner was happy to report that the squirrel mom did come down and take its babies and relocate herself and its babies. Success story.
Yay.
Get some heart emojis floating over the screen here. Glad to see that we solved the immediate problem of the bad panels. We solved the unhoused squirrel problem. So hopefully they are properly housed right now. And by installing critter guards around the perimeter of the array, the squirrels will no longer build a nest under that. And we have the same situation happen with pigeons sometimes too, especially on tile roofs. Let's go from the roof down. Let's talk about the all the way down. The most common problem we have is, and this is a famous quote from a movie called Cool Hand Luke with Paul Newman. The most common problem we have is, quote, what we have is failure to communicate. What kind of system communication problems are kind of common in the solar and the battery industry?
Yeah, so the most common communication issues are what customers say no production they see for like a day or a couple hours. And then the next day they'll message us and say, never mind, it's back up. So a lot of the time it's just the internet, poor internet connection, or sometimes their Wi-Fi extender just disconnects because of the poor internet, and all they really need to do is reset it. And then once they reset it, their communication is back up. I think communication is one of the biggest complications that customers see, is because of, location of where they live also could affect how their internet's working, the weather, like the recent rain, wind, I don't know, just everything in between.
What's our standard advice when somebody sends us an email or calls up and says, my system's not producing?
We say for them to wait at least up to 48 to 72 hours for the communication to restore. And if it doesn't, then of course we can take a deeper look into it, because majority of the time it will come back on its own. And if not, then like I said, we usually send them reset instructions, and once they follow that, they're able to get their communication back up.
What about cellular communication cards having a 5-year timeline? And any comments on that?
Yeah, I mean they had cell card that specifically, I think you're referring to Solar Edge having the 5-year cell plan, because that was a pretty common thing. They weren't as reliable as having a stable internet connection, like straight to your router or even a Wi-Fi connection, because it is a cell signal. So if you don't have good cell service at your house, then your inverter is not going to have good cell service for your system. But they did expire over time, of course, and then the communication would drop out. And kind of nodding to what Yvette said, is it would look like the system wasn't producing anymore. And so the homeowner would kind of have a freak out moment, and then you have a whole situation on your hands when it's just a cell signal that either went down or a cell card that expired.
So what's the most reliable form of communication for solar and battery systems?
Hardwiring it straight from a router is the best way. Lily knows that. Yeah, she likes to tell folks that that's the best way to do it.
Even if your system's hardwired, even if you have the most up to speed, high speed internet, best cellular connection, sometimes you can actually lose communication to server issues with the manufacturers. So that's also why we recommend waiting that 48-hour span. But like Lucas mentioned, hardwire connection with a reliable Ethernet cable from your router directly to the equipment's the best choice for communication methods. And you can also, even if the portal is showing your system's not working, if you didn't change your Wi-Fi password, if you didn't get a new router, you can verify the system's working by verifying the lights on the equipment to see if it's physically on while you wait that 48 hours.
Yeah, that's the communications. I mean, for me, going back even to 2001, it's always been the single most common cause of customers calling saying something's not working. All right, well, let's start talking about. We talked about a bunch of hardware. Let's talk about software and firmware. What are some of the common software issues, or more specifically, firmware issues that we see or we understand cause problems with customer systems?
Maya and I often see a lot of, we'll start off with is most of the time when we go to a site that's already having an issue, most manufacturers don't push their software or firmware updates remotely without a person on site. And so I think the idea behind that is to make sure that there is somebody on site while this is happening, just to be there ready if there is an issue while that issue occurred, maybe caused by the update itself, or if it gets stuck in the middle, it can be restarted and known at the time. But yeah, sometimes what we end up running into is where the software doesn't take, or it takes a long time for it to be pushed on, or it gets to one component but not to another component. And so then you have issues where they're just not working together so well because one's at one version of the firmware and then the other one's at a different version that's not compatible. Even connections to those units to get the updates pushed to them kind of varies across the different systems. Some we can do it by just connecting to the unit via the internet. Other ones we have to connect to a direct Wi-Fi or a Bluetooth connection to the unit. So far, what I see is that the system that we work with, that we connect to the internet and we're talking to it, is directly downloading it from the internet versus from our phone to the devices. And I think maybe even that's probably one of the best ones so far, because if they have a good stable connection to the internet, we're not running into those cellular connection issues. We have good Wi-Fi or a good Ethernet connection. That's a much faster and usually a much more stable connection.
Okay, let's dive back into the batteries themselves. Battery warranties that I'm seeing in the industry right now are typically between 10 to 15 years. How have these warranties been holding up in reality? And, we've been installing some of these battery systems going back 7 or 8 years. How are the predicted lifespans, the warranted lifespans, holding up based on the reality of what we're seeing?
Battery systems that I've worked with, most of the systems, the companies are still around. And so therefore, we're actually able to get a hold of somebody to talk with them or talk through the situation. There's definitely some systems that have more issues than other ones. And so kind of what Lily was touching towards earlier with the whole warranty portion is that the homeowner is might get a replacement unit that's covered under the manufacturer's warranty, but the actual truck roll for the installer to go out there is not part of that manufacturer's warranty. And so if you have a system that's older, closer to 10 years or over 10 years that's lasted that long, you're looking at possibly having more labor costs to get that thing running again.
I'd also like to touch on the fact that if your battery manufacturer went out of business, these batteries are so firmware and software dependent. So if that battery manufacturer did go out of business, good luck finding an installer that can get it working again. We've run into a recent manufacturer that went out of business, and these people have batteries that are only a couple years old. And once they run into an issue where they need a firmware push, there's no firmware that exists anymore, and the batteries are just bricks.
And I'll be specific since the company is no longer around, but that was SunPower. They had really good solar panels. They were using pretty good inverters and really good inverters with Enphase. They had their own battery system. But when SunPower went out of business a couple of years ago, even though the batteries were still at customer sites, there was no longer any software connection to the SunPower servers to make them work. And they basically were bricked. And I'm not talking about a little brick. How big are some of these batteries?
Some of them can weigh up to 400 pounds. They're huge. The battery that you're referring, yeah, there you go. The battery you're referring to, Barry, we actually call it a coffin because it's kind of shaped like a coffin, and it has multiple components inside of it. And specifically, it has 2 battery packs, and I think each battery pack weighs about 100 pounds. So yeah, when Lily says brick, it's not like your average brick here. It's kind of a brick about the size of a suitcase that weighs upwards of 200 pounds.
And usually it's a two-person job. So, you just can't send one person out to repair it. It takes 2 people to lift those things and put them in a truck and bring them back to our office and then properly dispose of them. So it's an expensive process just to get rid of the old batteries.
I was going to add a little bit more. The company being around, even if the company is around that on the older system, you also have to have somebody that's certified to work on that too, right? And so we ran into many years ago with, say, the SunPower situation, which is they have an installer network where we had to be in the installer network in order to even maintenance any of that system. So same with other manufacturers, they want you to be certified on that product. So if you're not certified on that product, you really can't even work on that product anyway. And as systems get older, the certifications / even the know-how of even working on any of those systems is slowly goes away.
This is more towards the firmware issues, but there's sometimes issues where installers don't even have access to the fix for the issue, and they send out the manufacturer to push a firmware update on a little hardware disk, and that's something the installer can't even assist with necessarily. That's all the manufacturer.
Okay, so let's go back up to the roof. Rooftop optimizers and microinverters, they usually have a 25-year warranty, and that's a long time. I would say many of the solar panels aren't going to be, really cranking out power after 25 years, but that's pretty good. What's your experience with the warranties on those optimizers and microinverters? Are they kind of look like they're moving towards that 25-year lifespan, which, by the way, if you have 25 microinverters or optimizers on a roof, and the average guaranteed lifespan is 25 years, once a year, you're going to have a problem. I just was kind of anecdotally observing. I think those warranties are better than that. We're not seeing every 25 panel system have an issue every year.
Over the years, both microinverters and optimizers have progressed greatly over the years, because in their infant years, when they first came out with those different products, they did really well at first, and then they started, not having such great reliability. But now that they've been in the field for many years and they've worked through a lot of the problems, I think both the rooftop electronics, major electronic companies, both of them have really made some really good changes for those products. And so we don't see very many failures on optimization or microinverters as we used to. I'm sure there's some companies out there that are still in their infant stages that are working through their bugs too, though. Rooftop electronics have definitely come a long way over the years.
And one good thing about a microinverter is if you have 25 panels and 25 microinverters and one microinverter goes out, your output of the system is only down by 4%. It's not a disaster. It's not an emergency. It might take a few weeks to get it fixed. Not such a big deal. But with a string inverter, especially the older, more unreliable ones, if one of those go out, it still might take a few weeks to get it fixed. But during those few weeks, your system's not working at all. Really, really important for companies that have string inverters, whether or not there's an optimizer on the roof, but really important that those string inverters be rock solid, reliable, because when one goes out, your entire system's down. How are you guys seeing the reliability of the string inverters, in this day and age?
Yeah, I think it's changed a lot. I mean, equally to the rooftop electronics, the technology's come a long way. Right now, we've been putting in Tesla string inverters, and they're pretty reliable. We haven't had any problems with them yet, knock on wood. Also, the inverter is the most sensitive part of the entire system. We've learned that over the years. The modules are generally not a problem. So, being that it's the most sensitive part, it's transforming energy every day. It gets really hot. We've learned a lot from the, couple decades that solar's been growing, and so try to keep it in a cool space, keep the sun off of it, all these different things. So like building dog houses over it can help too. But yeah, with string inverters, they like you said, Barry, once it goes down, it goes down. So they're completely out of power, and the homeowner typically is pretty upset. And depending on the time of year, it can be a pretty big problem for them.
In the past, like I was saying with the modular electronics on the roof, basically progressing in reliability. The inverters have too over the years, because there's a number of inverter manufacturers in the past that their manufacturing method was not as basically they had a lot of open air circuitry that was getting all the moisture, and if it was a close to the ocean, then you get the saltwater air that would go across these boards and create corrosion. Over the years, I think a lot of companies have kind of noticed that this is a problem. It's an outdoor unit. It might be in close to a saltwater environment. It might be just getting rain mist blowing on it, whatever. But so they've been kind of sealing these units a lot more and making it more of a closed loop on their cooling by using either just a heat sink, or using, I think Tesla's using a liquid cool system where they have like a little radiator in there with a fan. But with the ones with even the fan, you do have that moving part that is a failure point. And so that's typically the fans don't fail that often as they used to. I've seen a lot of them in the past that where they'd kind of warp a little bit and then they just gonna get replaced. But the rest of the components are fine.
And just kind of thinking about the almost 100% of the systems we're installing have batteries. So there's a battery system and an inverter. And a couple of the most popular battery systems, particularly the Powerwall 3, but also the new Franklin A-Power S. I don't seem to recall an inverter box that we have to install. Where the heck is the inverter on those Franklin and Powerwall 3s?
That's an integrated inverter. So both the Powerwall 3 and the Franklin have an inverter inside of the battery. So you kind of got cells on the bottom of the unit and an inverter on the top, but you would only know that if you had the cover off and knew what you were looking at, where everything's integrated. It's actually pretty slick, because then just less components for everything, less failure. I've replaced one Franklin inverter over the last, almost 2 years here servicing them. And I thought that was pretty cool that they actually were able to replace the inverter and let the cells stay in the unit, instead of having to just, throw the baby out with the bathwater or whatever.
Frank, what's your experience with in the battery systems with integrated inverters?
It's a pretty slick setup. It makes the installation much faster. My biggest worry would be is that it's not all one component. So if you have a failure on one side or the other one, you have to remove this whole unit. Luckily, a lot of the manufacturers have now came out with their own little dolly where we can a lot of times do it with one person, at least to get it off the wall or whatnot, or roll it around. Definitely should have a second person there to help you with the maneuvering of that battery, and if you're taking it or bringing it in and out of a vehicle. Yeah, I think it's pretty cool. I mean, most of the Powerwall 3, it's a cast aluminum enclosure that's been completely welded shut in the back, and so it's in there. It's a complete unit. It's one and done. I don't 100% know so much about the Franklin S, if you were able to remove that unit or not, but Franklin seems to be pretty innovative in their approaches on things. So
when I kind of look at systems, it's nice when there's just one battery unit with an inverter built in. And sometimes we'll use a meter collar adapter. Sometimes there just might be a separate interface box, like a Mac box, but really simple. And then there's other systems where you kind of get the delivery to, we're unloading the truck and there's like 5 separate boxes that we have to install. And each box has wiring, power wiring sometimes, and communications wirings going back and forth. What's our experience been just kind of looking at it from a high level as far as, which kind of systems are, let's just say, better? The ones with lots of boxes and lots of wiring, or the ones that are simpler, but they may be heavier?
I'm sure Frank and Lucas have some experience, but the service team as a whole doesn't have a lot of experience with these integrated components yet because there hasn't been enough issues to involve us.
Well, that means that they're not having as many problems, which is kind of good. I remember with Franklin, the first time, we had a problem, it was like, we didn't even know who to call because it's never happened before. And we installed, hundreds and hundreds of systems.
Lucas's experience with the one broken Franklin battery, it wasn't a Franklin issue. I'm pretty sure that was the one that was just a mouse that got into the side of it. And I'm pretty sure that's the one that he's talking about.
I mean, Franklin's failure rate is like incredibly low, but yeah, I've replaced three batteries and one inverter, and one of them was the rodent had chewed on the switch that will actually turn the battery off, just the integrated switch. So because they had chewed it and severed the connection, the thing thought that it needed to be turned off. When you have one system under one umbrella, it's always going to be easier to track down a failure, easier to deal with technical support. And if you have to replace components, at least you're only dealing with one manufacturer. Whereas once you start having multiple manufacturers, there's a lot of integration, like we were speaking on earlier with firmware and software, they have to talk to each other. And so typically what we've seen is when you have two manufacturers or three, whatever, and there's a failure, they start pointing at each other and start saying, oh, well, it only failed because this firmware was pushed from this other unit, and then it made my battery fail, or the firmware from the battery killed the inverter or whatnot. So, and now with the inverters that are DC coupled, that's when your solar panels are coming straight into the battery, and that paired with the meter collar, which is a slick device that goes right underneath your utility meter. I mean, the system's just really simple, really straightforward. It's kind of the way that the industry is turning right now, which is it's funny to us because as service technicians, we're typically used to going out to an older system with 2, 3, 4 different boxes that we can open up, and now we go out to these systems and there's just a battery. That's it. That's the only thing we can access. So, and that's pretty nice. That's, I think, what the industry should be turning towards.
When we have the pointing of the manufacturers, it's typically when you're working with a DC coupled system, because it's a little different because they're actually trying to really charge and discharge that third party unit, where they have to actually talk to each other, where an AC coupled system doesn't really have to talk to that solar system. It's basically just reading what it's doing and then charging or discharging according to that. And then it has its capabilities through like frequency shifting or whatever, to shut that system off. It just off or on, and what are you doing? And so AC coupled systems have that advantage, but if it's two different manufacturers.
Well, we talked a lot about the hardware that's installed on the roof, on the wall, ground-mounted solar and batteries. What about the hardware that's in the customer's pocket? How is that working? I'm particularly talking about the cell phone app, and what are some of the issues that our team sees with the apps that customers have, whether it's just questions about the app, people have to learn about it, or maybe possibly bugs?
There's a lot of issues with the accesses they give homeowners versus the accesses they give installers, and maybe what we're seeing doesn't line up with the exact window that the homeowner's seeing, or maybe we want to turn a setting on behalf of the homeowner and we don't even have access. So there's a lot of improvement that these manufacturers can do, and I'm sure they're working on it, to improve user friendliness for both the end user, the homeowner, and us installers to help them with that.
It also has to do with just typical app itself sometimes. Just like any other app, it could be buggy or wonky just at random times.
I see that. And then I also see there's a tremendous amount of controls and features and settings on these little apps that you have to interpret on, a tiny little screen. And so sometimes there's something that the customers don't even know about. And, that it might have been, it may be a setting that's very hard to find that is causing the whole problem.
I'd also like to add that there's so many user guides and information that the homeowners should know about their apps. We answer a lot of questions that were in the user guides. So if you're spending the money for these intricate battery systems, I definitely would recommend reading up on all the features they have and how you can control them.
A lot of times people put in a system and we kind of analyze the output of the system and analyze the roof and everything. And, they might have a 30-year-old house and the roof is never leaked, but the roof is maybe 30 years old. What's the process when somebody has solar on the roof, solar panels on the roof, and then they need to fix their roof? It's something that we call a remove and replace. How common is that, and what are kind of the steps that we have to go through to address that issue?
We probably do a removal and reinstallation or replace about once a month, not only for systems we installed, but other homeowners who have systems on their roof where their manufacturer may have gone out of business. But we basically have to remove all the panels and then we reinstall them, which is costly. And if the system is more than 15 years old, or if they have really old components with a manufacturer out of business, even if it's like only a 12-year-old system or a 10-year-old system, sometimes the finances don't line up where it makes sense to put those old panels back on the roof. So it's very prudent to think about the age of your roof and the condition of your roof, not only so you don't run into leaks or surprises or run into having to do a removal and reinstallation for the life of your system, which is another 20 years. So if you don't think your roof is going to last another 15 plus years, maybe you should replace it before you get your system installed, or be aware that there will be costs associated with all the labor to remove and reinstall it.
One of the things that I've noticed is that, for example, a system that was installed 20 years ago, those solar panels might have had a 15% efficiency. That's when they were new. They may have older inverters that had a 94% efficiency. All that's gone downhill. So if you kind of look at the real world efficiency of that old system, it might only be converting energy at 10%. And the newer systems, I mean, these solar panels have an efficiency of 22%. So a lot of times, once the system's 15 or 20 years old, you're going to get twice as much energy out of the same space on the roof, brand new equipment. And that's a pretty big improvement.
Over the years that like you're mentioning there is the panels themselves back in early say 2007 through 10, whatever, I think we're maxing out panel sizes of 185 watts, and now we're installing 460s. And I mean, the panel is bigger, it is physically bigger, but it also is that much more output than what you had at 185 versus 460. So yeah, like you're saying, in the same footprint, you can increase your output. I think what I hear from a lot of homeowners is they're trying to weigh out. It's like, okay, well, my system is producing this much. Is it meeting or exceeding, or am I underproducing what I'm needing nowadays? Because my demand has changed because now I have an EV charger, or I put it in a hot tub, or I have this or that, or whatever's changed my life needs. And so replace when you want to remove it, a lot of times it makes more sense to upgrade it to a much larger system, sometimes even doubling your output.
That's a candid, honest recommendation. We're not trying to sell stuff. We're just basically saying you can get a lot more power out of your system. And it's questionable if that 20-year system is going to keep working for another 10 years.
Also have a system that is over 15 years old and your roof could probably last a couple years. I would waiting to replace your roof until your panels get more life out of it.
Dovetailing on what Frank was saying about your demands changing, that's just a huge thing because everything's electrifying now. Electrification's huge, and people are, if you're going to swap out your AC unit, you're probably going to swap it out for a heat pump, and then you're going to end up using more electricity. If you're going to replace your car, it's common to buy an EV after that. You're going to use more electricity, even things like your stove top, and then you switch it out for an induction stove. So I mean, with the industry changing how it has and the efficiency changing as much, when you're thinking about replacing a roof and you're looking at the system that's pretty aged and possibly less efficient than it was 10 years ago, it just makes sense to replace the whole thing, at least the module, the inverter. I mean, now we might start looking at doing re-roofs when a battery is 5 years old or something like that. So that could be different, but it's a decision to be made. But electrification is pretty big.
Let's talk about a couple of factors that affect the system output, but it's really nothing at all to do with the system design or installation. It's the middle of the winter, it's rainy, it's cloudy, the sun's low. What do you say to customers who call us up and say, gee, my system's not working like it used to. Come on out and take a look at it. And these are generally customers that have had a system for less than a year. What's the problem?
I hear often even on new systems where homeowners are like, is this what I'm supposed to be producing? It's like, well, it's December, right? I mean, okay, well, it's cloudy a lot more of the days in California than it is during the summertime. And so you have a short actual sunny day when it is sunny, and you have a lower sun. So like you'll see almost a 50% drop between what is it, June, July to December, January. Completely different output. And of course, like you're getting to is like over time, you have trees and whatnot that are growing, and things start overshadowing from growth, and things get dirty. So if you're in a high construction zone or even a farm zone or whatnot, where you have a lot of dust that's being brought up into the air, that stuff's going to land on the panels. And I like to use the analogies like if you left your car sitting in your driveway for a year and you never drove it and you went and sit in your car, how well could you see out your windshield? If you can't see out your windshield very well, it's almost the same as the solar panels trying to see the sun. Basically, it's impeding that power to get through for that to be converted. So your panels get dirty. You're going to produce less. And even the new construction process itself is dirty. And we could put brand new panels on the roof, brand new construction, and they finally turn it on 3 months later, and it's underproducing because it's dirty from all the construction.
So I'm just thinking, Frank, you gave me a really good idea. So when I leave my car in the driveway for a long time and the windshield gets really dirty and I get into the car, there's a button I can push to clean the windshield. Is there a button that a customer can push to automatically clean those 20 solar panels on the roof?
No, not a free button. There's the button on the computer to hire somebody to do it, or you can do it yourself if you're that inclined to do so. But yeah, in the same situation with the vehicles, like if somebody wanted to do it themselves, I say just use whatever you would use on your car. Nothing corrosive, nothing abrasive, and then be careful around the panels. Don't fall off your roof.
I seem to recall a video of Lucas intrepidly standing on the roof with a harness with the cleaning system. Tell us a little bit about that cleaning system, Lucas.
Yeah, I wore a harness that stayed safe the whole time. Harness is very important. If a homeowner is going up there to do it themselves, they should definitely install a harness. No, I'm kidding. They shouldn't be putting their own harnesses in. That's dangerous. But yeah, the cleaning system that we use here at Cinnamon is a reverse osmosis, I believe. And so we get very clean water, essentially, to not leave any streaks, but more it has to do with scaling. It has to do with not leaving the hard water on the panels that can then have mineral buildup. So, but I mean, using a soap, I think is okay too. But yeah, cleaning the panels is pretty huge. I think that you can see as much as like a 5% increase in production.
If I look at my panels and I'm not in a really dirty area, but typically the output can go down by 15% or more from when it was new. And then when I clean it, I can get almost back to where it was before. It improves it by 10, 12, 13%. But then in 6 months, it gets dirty again. Not really, really dirty, but it's dirty again. But yeah, having those reverse osmosis systems that the worst thing you can do to clean your solar panels is hose them off, because that's going to create some mineral deposits on the roof. If you want to do it by yourself, use some kind of dish soap or car wash solution that's got some soap in there that's going to dissolve those minerals, and then just rinse it off very gently.
This is years ago, but I went to a customer's house. It had Now it'd be almost 20. It was probably 5 or 6 years old, 15 years ago. And he had repainted his house, but he didn't cover his panels. And so there was tons of overspray all over those panels. And imagine trying to get paint off of your glass window. It's the same situation. So that's another thing to be careful about is if you're doing painting, even if you're painting gutters or your fascia board or your house or whatever, any overspray is definitely going to reduce the output.
Don't trust the painters to not spray the panels. You have to basically make sure that they're masked because it's really hard to get that paint off. What do you do about trees growing and creating shade? What time of year would you see the biggest impact?
So you'd see the biggest impact in the winter because you're already operating at a reduced capacity compared to the summer. And sometimes even with these tree overgrowths, it can cause so much shading that the system, like the inverter, is not getting enough voltage to even produce during the day. We see that situation happen when people have smaller size systems with tons and tons of shading. So we recommend trimming those trees regularly. And if you trimmed a lot of trees before you got solar, you kind of have to maintain that. Otherwise, you'll see a dip in production, especially during the winter.
That makes sense. Any final comments or suggestions that you think would be helpful to solar customers?
Don't forget to check your solar. Like, keep an eye on your app. A lot of times what we see is people don't keep an eye, for the first couple of years, they'll keep an eye on it, and then they stop looking at it, and then they get a utility bill that's ginormous, and they're pretty upset. So one thing is, if you need to set a reminder for once a week just to open your app and look at it, do it, because a lot of times with string inverters, when it goes down, the whole thing goes down. So you stop producing. If that happens in June or May or July, you lose a whole month of production, you're going to end up with, several hundreds of dollars of utility bill that you didn't intend to have.
Yeah, like what Lucas is saying, we would recommend checking it at least a couple times a month, not every day. Definitely don't check it every single day, like every so often during the day, because of course you're going to see differences each day, but definitely a couple times, within the months, at least checking on the app.
When you do check the app, we recommend just making sure, is my battery charging and discharging? Is my system showing zero production for a couple days? Those are the types of things that probably need some action from the installer or settings change to remedy. But if you see just variance in production or variance in battery discharge behavior, that's probably not an issue.
Kind of reminded me just one thing that's really, really important, and it's becoming more and more common, is that with battery systems, some of them are connected to virtual power plants or VPPs. And those VPPs allow the utility to use some of the capacity in your battery. It usually happens in the late afternoon or evening. And so customers say, oh, why is my battery discharging? This is when I need the power. Well, that's part of the VPP, and you're sending power to the utility and you're getting some money back for that. The other thing that we found is that some of the battery systems have a calibration cycle. And so it may be, in the middle of the night or really bizarre times where the batteries suddenly start discharging. And that is a feature. That's a standard part of a lot of these battery systems where they have to occasionally be internally calibrated, and you kind of don't have any control over that, but just be patient. There's nothing wrong with the battery. There's nothing we can do about it or your solar installer can do about it. It's just part of the battery management system.
I'd also like to mention taking advantage of features when you have a battery, such as storm protection, making sure your battery reserve is at 100% before you have a possible PG&E outage or whatever utility company you have outage. Um, Staying on top of the features of your battery can prevent you running into an outage when your battery's only at 20% and can't provide for more than a couple minutes during an outage.
Okay. I'm really, really glad that we had our team here, the service team, the field service people, the service coordinators internally. Boy, there's just a lot of suggestions. I think we went longer than we had anticipated, but it's worth lots and lots of good information here. I just want to thank Yvette and Lily and Lucas and Frank for doing such a great job and for joining me on this week's Energy Show. So that's all the time we have on this week's Energy Show. Thanks for joining me. And thanks to all of our listeners for tuning in. And if you have missed any of today's show, you can always go to our website at energyshow.biz and listen to the podcasts.
Thanks for tuning in to this week's Energy Show.